Russia fights at continental scale, so its logistics think in trainloads, not truckloads. The backbone is a vast Soviet-era rail network on a wider 1,520mm gauge, built to move heavy cargo long distances with fewer people and less fuel per ton than road convoys. In wartime, bulk munitions, fuel, spares, bridging kits, and replacement vehicles flow by rail to major hubs in the western and southern military districts. From there, a hub-and-spoke pattern pushes supplies to forward railheads, the last big stations judged safe enough, where cargo is cross-loaded to trucks for the final run. This doctrine trades flexibility for throughput. Trains deliver mass reliably, and dedicated railway troops can repair tracks, bridges, and catenary fast. But the same fixed nodes, bridges, junctions, marshaling yards are predictable targets. The system works best when distances are long, routes are secure, and schedules hold. When strikes, sabotage, or seasonal mud disrupt the plan, pressure shifts to the last mile, where Russia's road fleet, handling gear, and drivers have to absorb the slack. War runs on inputs: explosives, propellant, steel, fuel, electronics, rubber, bearings. Russia's system begins in dispersed factories, some modernized, many inherited from the Soviet map, tasked to push out artillery shells, rockets, armored vehicle parts, drones, and spares in steady batches. Think of it as a pulse. Components arrive from feeder plants, assemblies move down lines, finished lots are stamped, crated, and queued for shipment. Parallel to this, state fuel refineries blend and route diesel, aviation fuel, and lubricants to military depots. Because no factory hits 100% of needs, the system supplements from outside. Licensed parts, dual-use electronics, and foreign ammunition or components that slot into existing calibers and platforms. Everything is standardized into rail-friendly units. Pallets, crates, ISO containers, fuel wagons, so one paperwork trail can send thousands of tons with minimal handling. Security and dispersion shape the layout. Big national depots hold deep reserves, regional depots buffer flow, local forward depots handle daily issuance. The timing matters as much as volume. A plant that ships late ripples delays across a whole sector. Once a shipment is cleared, loadmasters push it onto flat cars, gondolas, boxcars, or tankers. The moment doors slide shut and seals are placed, the cargo stops being factory output and becomes train tonnage, ready for the long haul to war. Picture a conveyor belt the width of a continent. That's Russia's rail. Trains leave interior plants in timed waves, each consist built for a role. Open wagons piled with ammunition crates under tarps, tank cars of diesel, box cars with spares and rations, flat cars with bridging sections or trucks chained down. At major junctions, dispatchers stitch these waves into prioritized corridors, green lights for military freight, so the flow keeps moving. The advantage is ruthless efficiency. One crew, one locomotive set, thousands of tons hauled for a fraction of the fuel and tires a road convoy would burn. As trains approach the theater, they peel into macro hubs, vast yards with cranes, repair tracks, and guarded sidings. Here, loads are checked, sorted, and assigned to forward axes that mirror the ground campaign. Railway troops shadow the movement, ready to weld rails, lay prefabricated track, or throw up a temporary bridge if something breaks. The rhythm matters. If a hub clogs, the entire axis starves. If it runs smooth, artillery batteries downrange feel it as steady resupply, not feast and famine. A railhead is the last big station you dare to use. It's where long trains become many small piles, pallets of 152mm shells, crates of rockets, drums of oil, boxed spares, rations. Cranes and forklifts lift cargo into waiting trucks while clerks stamp manifests and guards keep prying eyes away. In theory, the closer this node sits to the front, the faster units get what they need. In practice, proximity turns railheads into magnets for trouble. Enter the HIMARS effect. When long-range precision strikes started hitting large depots and rail-served warehouses, Russia shifted tactics. Big, centralized stockpiles gave way to depth and dispersion, pushed the bulk farther back, beyond typical strike envelopes, and spread forward stocks into many smaller dumps hidden in tree lines, farmyards, or industrial lots. That reduces the risk of a single catastrophic hit, but it also changes the math. More dumps mean more handling, more trucks, more drivers, and more scheduling to keep all those little mouths fed. The paperwork changes too. Instead of one hub issuing big, predictable lots, you get a patchwork of just-in-time runs that are harder to coordinate and easier to delay. And because the railhead moved back, the last mile got longer, often 50 to 100 kilometers of vulnerable roads. Efficient when it hums. Brittle when a bridge is out, a driver is short, or a forklift throws a belt. Past the railhead, the war runs on trucks. A good last mile looks boring. Staged pallets, fueled vehicles, rested drivers, clear routes, and a dispatcher who treats minutes like ammunition. Russia's challenge is converting rail mass into steady, small unit deliveries across pockmarked roads under watchful drones. Every extra transfer, wagon to yard, yard to truck, truck to forward dump, adds delay and damage risk. Capacity hinges on 3 levers. Fleet. Enough cargo trucks, fuelers, wreckers, and lowboys to move heavy kit and recover breakdowns. Handling, forklifts, cranes, pallets, slings. Without them, soldiers become stevedores and throughput collapses. Route discipline, convoy spacing, blackout or smoke where needed, bridge weight checks, and alternate tracks if a culvert fails. When these align, artillery batteries feel it as rhythm. Fresh tubes, propellant, and shells arriving before the last crate empties. Then the terrain votes. Rasputitsa turns dirt cutoffs into axle-deep soup. A detour from 10 kilometers to 40 kilometers is a quiet disaster if repeated across an army. Winter can help, frozen ground stiffens, but ice punishes tires and drivers. Under fire, trucks spread out, run at night, or hug tree lines, which slows the cycle. The result, the short, last mile can devour the most time, fuel, and focus in the whole chain. A logistics map is really a list of critical points. Bridges concentrate risk. Destroy a key span and you don't just delay one convoy. You shove thousands of tons onto longer, weaker roads. Rail junctions and marshaling yards are similar. Hit them and you ripple timetables for days. Even a simple ferry crossing throttles flow under bad weather or attack. Crimea shows this logic. The Kerch Bridge once anchored a short, high-capacity route into the peninsula. Repeated damage forced traffic to share load with ferries and with the coastal land corridor through Mariupol and Berdyansk. That corridor works, but it's longer, more exposed, and strung with vulnerable bridges and causeways. Each detour adds hours, each temporary repair lowers confidence, and forces more stock to sit farther back. Further north, big rail hubs feed axes toward occupied cities. They're protected, redundantly wired, and quickly patched by railway troops, but they can't be invisible. A precise hit on a diesel farm or transformer cripples switching and delays everything from fuel trains to flat cars carrying bridging gear. In a system built on schedule discipline, choke point pain propagates. A single node's slowdown becomes a sector-wide rationing problem 2 or 3 days later. Modern deep strike and sabotage campaigns target logistics because they're predictable and slow to hide. Drones and missiles reach depots, fuel tanks, transformers, and bridges. Partisan cells use arson or small charges to bend rails or torch parked wagons. None of this wins the war in one blow. It does something subtler. It randomizes a machine that needs rhythm. On the ground, disruption shows up as variance. A train that should arrive Wednesday slips to Thursday night. A bridge rated for 60 tons is temporarily 30. A hub that normally flips a consist in 4 hours needs 12, while crews relay ballast. Commanders downstream react by over-ordering, padding requests to hedge against delays, while staff upstream hoard a little extra just in case. The buffer stock that used to sit near units shifts backward, and trucks drive farther, burning time and fuel. Russia counters with redundancy, extra sidings, rapid rail repair, decoys, night moves, and dispersion. These measures work, but they cost speed. The more you protect the chain, the less efficient it becomes. In a long war, that friction accrues like compound interest, turning today's nuisance into next month's shortage. When the front door creaks, logisticians look for side doors. Russia supplements domestic output with external corridors that move components, drones, or ammunition through friendlier lanes. The Caspian route mixes sea and rail, ports on the inland sea feed trains northward into Russia's network, useful for bulky or sensitive cargo that dodges crowded Black Sea lanes. Elsewhere, rail/sea links from East Asia deliver standardized containers that drop neatly onto flat cars or trucks. These routes aren't magic. Every transfer, ship to key to wagon, adds time and leaves signatures. Ports have finite berths, customs processes leave paper trails, and long-haul containers are easy to photograph and count. But side doors complicate targeting. Even partial throughput sustains pressure at the front by backfilling what domestic plants can't. The strategic effect is cushion, not cure. External flows buy time for factories to ramp, for rail repairs to settle, and for depots to refill. Cut them, and the whole system leans harder on aging stocks and longer internal hauls. Protect them, and you shave peaks off demand spikes that would otherwise starve units in contact. In the end, Russia's logistics engine is built for mass, not elegance. Rail can move thousands of tons per train with low fuel and manpower. A hard-won repair culture and prefab bridging keep lines recoverable. Dispersed forward dumps blunt single-strike catastrophes, and standardized pallets, containers, and tankers streamline handling. Yet those strengths expose seams, bridges, yards, transformers, and tunnels are fixed. Knowable targets. The last mile drags under truck shortages, limited handling gear, and road wear. Seasons punish secondary routes, and reliance on external flows opens political and kinetic attack surfaces. Net result, a machine that can haul war across a continent until it reaches the narrow band where precision weapons and mud do their best work. The seam between rail certainty and road reality. If you enjoyed this, please like the video and subscribe to our channel.